Next, we will continue our look at nucleophilic addition by enolates by focusing on mixed and directed aldol reactions. In the previous video, we looked at aldol addition reactions that were self-addition. So there was only one aldehyde present, and so the enolate that formed from that aldehyde would react with that aldehyde. What if we had two aldehydes present? Well, if we have acetaldehyde and propanal and we treat this with hydroxide, well, this can grab off one of these protons, which would lead to the formation of some of this enolate. And it's also possible that hydroxide will grab off one of these protons, leading to the formation of this enolate. Now what we have together in solution, because think about the position of equilibrium, we're going to have lots of aldehyde and a lot of enolates. So this means we have a nucleophile and another nucleophile and an electrophile and another electrophile. So it is quite likely that this nucleophile will add here and that it will add here. It's also quite likely that this nucleophile will add here and that this nucleophile will add here. So what we'll end up with is a mess. We will end up with a mixture of 4 different products that look like this. So the enolate derived from acetaldehyde can act as the nucleophile with the aldehyde of acetaldehyde or with the aldehyde of propanal. The enolate derived from propanal can act as the nucleophile with the aldehyde of acetaldehyde and with the aldehyde of propanal. So because each nucleophile can react with 2 different electrophiles, we can end up with a mixture of 4 different compounds. So a mixed aldol can be a real problem. So how can we avoid mixtures when we're trying to carry out an aldol between 2 different compounds? Well, it will help if we use an aldehyde that cannot form an enolate, such as formaldehyde or benzaldehyde, right? There's no alpha hydrogen, so no enolate can be formed. So let's say, for example, we react acetaldehyde with benzaldehyde. Well, the hydroxide can form some of this enolate to give this intermediate, and now this intermediate can react with benzaldehyde, and I'm skipping a step. This will lead to this, but there will still be acetaldehyde present, so this enolate can also add to acetaldehyde itself, which means you will end up with a mixture of 2 products. 2 is better than 4, but still, this is not ideal. Another thing we can try is to use an aldehyde that can't form an enolate and use one reactant that's less reactive toward nucleophilic addition. So here we have formaldehyde and propanal. This is the only one that can form an enolate. So let's see what that gives us. We make this enolate. Now this enolate can add to formaldehyde or it can add to propanal itself. And formaldehyde is going to be much more reactive. So the preference is that this nucleophile will add to this electrophile. And in this way, we can maximize the yield of this, plus a smaller amount of the other enolate, of the other aldol product that would look like this. By the correct selection of reagents, we can maximize the yield of one particular compound. Using one aldehyde that can't form an enolate, having that one act as the electrophile is good. If we have another reactant that can form an enolate and that isn't as reactive as an electrophile. Using formaldehyde is great because it can't form an enolate and nucleophilic addition to it is very easy. Using benzaldehyde, it can't form an enolate, but it's not necessarily more reactive than other aldehydes. So we have a little bit of a limitation. Keep in mind that when it comes to nucleophilic addition, because ketones are less reactive than aldehydes, we could use a ketone that forms an enolate that would not do self-addition reacting with an aldehyde that can't form an enolate. And that's a way that the reaction might work pretty well. But this still means that we have limitations in what combinations we can use, right? If we happen to want this particular compound, then sure, we can just mix these things together with hydroxide. But what if this isn't the target that we want? What if we want a target that derives from two aldehydes, both of which could form an enolate? Are we stuck with trying to sort through 4 different products at the end? Let's see if there's something else we can do. So far, as we've been talking about aldol reactions, we have been talking about using a base such as hydroxide to generate this enolate along with water. Thinking about the pKa values, this is 15.7 and this is about 17. Look back in your notes to check that. Water is the stronger acid, which means equilibrium lies to the left. So that means at equilibrium, we have some enolate, but we have more aldehyde. That's great when we want to do self-addition because we have enolate present and we have aldehyde present, and so they can react together. What if we don't want aldehyde left over for this enolate to react with? Then we need to think about using a different base. If we have an amine base, then that can grab off the alpha proton, form the enolate, and now we're talking about a pKa value of about 36 compared to about 17. And so this is the stronger acid, so the equilibrium lies very far to the right. What this means is that now we have present mostly enolate, and there's very little aldehyde for this to react with. So this enolate will just be sitting here, bumping into solvent molecules, and it's not really going to bump into one of these because there aren't very many around. So now if we added in something else, now this enolate can react with something else that we add in to give us our desired product. On slide 11, we talked about the mixed aldol between acetaldehyde and propanal, and we saw that that gives us a mixture of 4 products. Well, instead, what if we do a directed aldol? So with a directed aldol, we are still combining 2 different aldehydes, but by selecting the proper reagents, we can control, or we can direct, which one acts as the enolate and which one acts as the aldehyde. So let's look at these 2, but in different order. So first of all, what if we started with acetaldehyde and we treated it with LDA? This is our very strong amide base, so that's going to pull off this proton, forming some of this enolate. So because we're using LDA, we have mostly enolate, very little aldehyde. So we are not going to have significant amounts of this reaction happening. Nothing is going to happen until something else is added. So once we have converted acetaldehyde into the enolate, next, if we add propanal, we are now directing this enolate to react with this aldehyde. And so that will give us this, and then on protonation, it can grab off a proton from some water that's added as part of the workup, for example. And our final isolated product will look like this. So with a directed aldol, we can selectively obtain one aldol product out of a possible 4. What if we carried out this reaction in the opposite order? So we start out with propanal and treat it with LDA. That is going to give us some of this enolate, actually lots of this enolate. And now, because there is very little propanal for it to react with, nothing's going to happen until the second aldehyde is added in. And that means that we are going to get this intermediate, and then on aqueous workup, the O- can grab off a proton, and this will be our isolated product. So if we're thinking about acetaldehyde and propanal, we can make 4 different products. So if we want acetaldehyde to react with the acetaldehyde enolate, then we just do self-addition. If we want the propanal enolate to react with propanal, we just do self-addition. If we want this enolate to react with this aldehyde, then we react acetaldehyde with LDA, and then we add in the propanal, and that gives us this product selectively. If we want the enolate of propanal to react with acetaldehyde, then we treat propanal with LDA to give this enolate, and then we let that react with acetaldehyde to give us this final product. So with a directed aldol, you can control who is the nucleophile and who is the electrophile. It's important to take this under consideration to keep in mind when you can allow self-addition to happen, when you can allow a mixed aldol to happen, and when you need to do a directed aldol.